Hey everybody, we are in the Tennessee Reveal Geometry Lesson 2.5 on three-dimensional figures. And three-dimensional figures are what you think: cylinder, cone, prism, pyramid. It's all of those figures that have length, width, height, three things going on. Okay, so let's see. I am on page 107, I believe, of your book, but let me check that just to be sure because I don't have one sitting in front of me. Yeah, it looks like it's page 107. All right, so let's talk about what these things are. Well, first off, what is a polyhedron? It's a closed, and that means there's no opening, no gaps, three-dimensional figure that's made up of flat polygonal regions. In other words, no curves. No curves. So a polyhedron is your prisms, your pyramids, not a cylinder, not a cone, because that has curvature for like the circles. All right, so a face is one of the flat surfaces. So this is a pentagon. That is a flat surface, two-dimensional figure. It's a face. This is one of its faces, that rectangle-looking figure. This is another face, rectangle, or maybe even a square-looking figure. And then you have edges, which are kind of like where they meet each other, those little lines where one face meets another face. This is an edge, edge, edge. You kind of get the idea. Vertex is like a corner. That's a vertex, vertex. Got there a vertex in the back, vertex. For this pyramid, there's your vertex. This would be an edge. That line right there would be an edge, edge. All four triangles in this, what looks like some sort of parallelogram. Those are your faces. All right. Then you've got a little bit more specific of a face, and that is called a base. So for this pyramid that I'm looking right here, this is the base. Now you can have a triangular pyramid where the base is a triangle, but this is some sort of square pyramid or a rectangular pyramid because it is some sort of quadrilateral four-sided figure here. This would be a pentagonal prism, because the base on the top and the base on the bottom are both pentagons. And it's a prism because the other faces are rectangles. All right. Okay, so cylinder and cone, these are not polyhedron because they have a circular base. This cylinder you're looking at, these are your bases that are the circles. And for the cone, this is your base. That's the circle. This is your vertex up here. All right. Well, I don't leave a lot of room for the sphere here. Okay, this is a horrible looking sphere. Yeah, the one in your book is definitely a lot better. But for like spheres, think softball, volleyball, basketball. Think some kind of ball. All right. Okay, so here's they get into different types of prisms and pyramids that I was speaking of earlier. These all three are prisms. However, you can see what makes them a special type is the base. So this is a triangular prism because the bases, there's one and the other over here, are both triangles. This is a rectangular prism because the bases are rectangles. And this is a pentagonal prism because the bases are pentagons. There's your pentagon at the top and pentagon at the bottom. Here are three different types of pyramids. A pyramid is different than a prism in that it has a vertex at the top and not another base like a prism does. So this is a triangular pyramid because the base is a triangle, a rectangular pyramid because the base is a rectangle, and a pentagonal pyramid because the base is a pentagon. So If you have any questions about that, ask your teacher or leave me a message here on YouTube, and I'll be happy to maybe explain it better. All right. You've got a regular polyhedron where all of these sides are going to be the exact same. That's your basic cube. And, okay, here's a tetrahedron where it's a triangular pyramid, but all sides are going to be the exact same size. So 1, 2, and the triangle in the back, and even the base and the bottom are all going to be equilateral triangles, and then so forth and so on. All right, let's get into it, okay? If you have any questions, ask your teacher or ask me. All right, I'm on example number 1. I think that is going to be on the next page of your book, maybe page 108. Oh, yeah. So turn to page 108, and probably already turned there for those examples of the regular anyway. All right, so example number 1. Identify properties of three-dimensional figures. Determine whether each solid is a polyhedron. So they're looking for a yes or a no. Then identify the solid. That means what type it is. If it's a polyhedron, name the bases, faces, edges, and vertices. Okay, so the solid blank formed by polygon, polygon, you get what I'm trying to say. So let's see. I guess they want is or is not. Well, this is definitely is. It is, if you'll notice, let me see, where am I? Okay. I was thinking it had one of these up there, but I guess it does not. So this is a polyhedron. All right. There is no base. Okay, so there really is no base because it's not actually sitting on a side, or what you guys would need to start calling a face. So it has equilateral triangle faces. It has, well, let's count them out. Front, back, left, right. There's 4. Front, back, left, right. There's 4 more. So that would be 8. And 8 is octa. So this is an octahedron. Octahedron. All right, here we go. What are our instructions? Use keyboard. Okay. All right, so our faces. Now this is going to be kind of interesting to write. A face is like this triangle, QST. That's 1. And then you're going to have QSR, QRU, and then QUT for the top 4 triangles. Now we'll go to the bottom. TVS, SVR, RVU, and UVT. Now I got to be able to name all of those. So here we go. Oh, good. It's going to actually let me kind of see it at the same time. All right. So I said QTS. Come on. There we go. All right. QSR. QRU. And then QUT. Those are the ones on the top. Now to the bottom. TVS, SVR, RVU, and UVT. And that is super small. Way to go, you guys. Edges. Okay. We've got QT, QS, QR, QU. From the bottom, VT, VS, VR, VU. QT, QS, QR, QU on the bottom, VT, VS, VR, VU. And our vertices, Q, U, T, S, R, and V. Q, U, T, S, R, and V. 1, 2, 3, 4, 5, and 6. Okay, moving on. Let's see what we got here. Solid has a curved surface, so that is not a polyhedron. It has two congruent and parallel circular bases, so this is a cylinder. Need another example? Go online. I'm just going to go to the next page. Okay, so turn your page. We're going to be on page 109 of your workbook on example number 2. All right, model three-dimensional figures. Identify the three-dimensional figure that can model the beverage container. State whether the model is a polyhedron. Well, this is definitely not a polyhedron because it's a circular base at the top, a circular base at the bottom. This is a cylinder. Curved surface, so I guess they want, it is not. Okay, so it's not a polyhedron. Okay. All right. Going on to the check below this. Identify the three-dimensional figure that can model the top of the camping lodge. State whether the model is a polyhedron. Well, it definitely is. I don't see any curved surfaces like a circle. In fact, I see this triangle right here, which leads me to believe there is a triangle in the rear of the lodge. So this is a triangular prism. And it is a polyhedron. Okay, moving on. Okay, here we go. Getting to the formulas for surface area and volume. S stands for surface area, V for volume. Now, some things to be aware of. P is perimeter of the base. Now, I will have a lot of students that will look at this prism and look at this pyramid and will be able to tell me the base on the pyramid, but they're not sure which is the base of the prism. Now, to be honest with you, as long as you're consistent, it really doesn't matter. If you want to say the bottom and the top is the base, not a problem. If you want to say the front here and the back are the bases, okay, not a problem. You've got to pick and be consistent. Like I can't say, okay, I'm going to make this bottom here the base and the front the base. It doesn't work that way. If you go at the bottom, you got to go at the top, the opposite. If you're going to go with the front, you got to go with the back, the opposites, because those are the ones that are matching up. Now, as for the pyramid, it's usually the one it's sitting on. But every once in a while, they might change that up. All right. B is the area of the base. So like for this pyramid, you would be finding the area of this one base here. Now, for curvatures like the cylinder and the cone, you got to remember the formula for the circle, which is pi r squared. And that would be your B. But it does come in the form usually with a pi r squared. But every once in a while, you'll have a teacher that will put this as a B right here for the base, because the base is a circle. And to B right here because the base is a circle. And so something to watch out for. Volume is BH for the prism. And it's also BH for the volume over here, but this B is a pi r squared. So please keep that in mind. Some teachers will just have it a B And some teachers will be a little bit more specific of, hey, this is a prism, so it's a rectangle or something to that sort, triangle, whatever it is, the formula, and then they'll say, okay, well, the circle is pi r squared. All right. Example number 3. Let me turn to the next page in my workbook for you guys. Can I keep up with where you guys are? It looks like I'm going to find surface area and volume both. Okay. All right. Well, first off, this is a cone. So I'm looking over here for the formula. So when you got a pi, we need to know the radius. And this L, I forgot to mention, is not an actual height. That is called your slant height. So think about if you're in a building, the elevator is true height. It's going straight vertically up and down. Slant height is not the same thing as height. It's the slant of the cone, how much it kind of leans, so to speak. And then pi r squared for the circle. And then the volume is 1/3 pi r squared h. So this h is the true height. And the L for the surface area is your slant height. All right, here we go. Well, I see that 15 is being pointed towards that little red line, which is my radius. And the 8 is on the inside of this cone, which is my true height. And I do not have the L, which is slant height. But I do see a right triangle sitting inside the cone, which means I need to do the Pythagorean theorem to find the hypotenuse of this right triangle, which is the slant height L. And that is exactly what they do for me. A squared plus B squared equals C squared. A squared is my 8 squared, B squared my 15 squared, and my C squared for the Pythagorean theorem. All right, so they ended up with 17, or approximately 17, the square root of 289. All right, okay. All right, so we're just plugging in. So we're going to plug in pi times my radius, which is 15, 17 for the slant height, plus pi, and then again plugging in my radius of 15 squared. And okay, well, you can't really see it, but there is the answer, which is luckily in your book, because once again, McGraw-Hill does a horrible job of showing. Okay, volume, moving on. 1/3 pi r squared. So I do need to put in that 15 to the second power, I suppose. 15 squared. All right, and then times 8 gives you 1,885. And remember, volume is cubic. So area is squared inches, and volume is cubic inches, because you're talking about three objects going on here. Okay, all right, so let's do a check here. Volume is the easiest because this is a prism. It's just length, width, and height. And again, if you're wondering, well, hang on, how'd you know that? B is the area of the base. Now remember, the base here is this rectangle, which is just length times height. And then you have the height of the prism. Now, if you're a teacher that's brand new, you will definitely have students that will get height of the base and height of the prism confused. So you need to be able to make sure they know how to find the area of the base and then multiply that times the actual height of the prism. Okay, with that being said, length, width, and height. You're just going to multiply the 3 numbers because in the prism, it's just really that easy. So grab a calculator, multiply 6 times 5.2 and times 10. And you should be looking at, 312. I had to get my calculator ready. And for surface area, going back to this formula, you're going to put in the perimeter of your base times your height plus 2 times the area of the base. All right, so perimeter times the height plus 2 times the area of the base. All right, so I'm going to make the 5.2 and the 10 my base, and I'll make the 6 the height of the prism. So I'm going to find the perimeter of 10, 5.2, 10, 5.2. That's going to be my P times the height, 6, plus 2 times, and again, this is my base. There's my length, there my height of the base. So it'll be plus 2 times 5.2 times 10. All right, do that on your calculator. Should be getting 286.4. All right, listen, if you are stuck, you have any questions, ask your teacher. Leave me a message here. I'll get back to you. All right, moving on. Next page. All right, example number 4. It says calculate the measurements by using three-dimensional models. All right, we got the New Year's Eve ball. Is a geodesic sphere. Okay, so it's not like a true sphere. It's not totally curved. That is 12 feet in diameter. It weighs 11,875 pounds. Is lit by 32,256 LED lights and is covered with 2,688 crystal triangles. So it's not a true sphere because it's not completely just circular. It has triangles, crystal triangles. In fact, I guess that's why they call it a geodesic sphere. All right. How many lights are contained on the ball surface within the area of a 4 square feet? And all right, step 1, find the surface area of the ball. Okay, so let's go back to the formula for a sphere, which is for the surface area. Go back to your page 109, and the formula is 4 pi r squared. 4 pi r squared. So we got 4 pi. And if the diameter is 12, remember we have to divide that by 2 to get the radius of 6. So it should be 4 pi times 6 squared. 4 pi times 6 squared. I'm not sure why I'm putting it twice. Oh, why am I putting it twice? Oh, okay, they wanted just the R right there. Forgive me. R. That's an F. How about an R? And then 6. All right, so remember, don't multiply 4 times 6. Multiply 4 times 6 squared. So square the 6 times the 4, and then times your pi. Use your calculator. You get 452.4 square feet. Remember, surface area is square. Area is always squared. All right, we're going to move on to step 2. All right, so we are doing kind of a conversion here of how many lights it is. So there's 32,256 lights out of 452.4 square feet. And the square feet are going to cancel. And you can basically just grab a calculator and multiply this straight out. So that's going to give you 285 lights. Yeah, 285 lights. So there are 285 lights within the area of 4 square feet. All right, part B. Tony is repairing a section of the ball that has a volume of 8 cubic feet. How much does the section weigh? All right, we need to find the volume. Now, the formula for the volume of a sphere is 4/3 pi r cubed. See, I'm learning. The radius, again, is 6 because the diameter was 12. And you got to take that diameter, divide by 2 to get your radius. All right, so we're going to do 4/3 times pi times 6 to the power of 3. So 4/3 times, what do they want? Okay, they want me to do the number before the pi. So it'd be 288 pi, and then 288 times pi is approximately 904.8 cubic. That's a cubic. All right, step 2, convert that with the amount of light. So we've got 11,875 pounds into 904.8 cubic feet. And of course, the 8 goes out front because that's your volume right there. That's where the 8 comes from. And do the math, we get 105. So basically, it's, 105 pounds? Yeah, 105 pounds. Okay, we've got a check here. Mateo is building a new pool. A cross section of the pool is shown. All right, what's the volume of the pool to the nearest tenth? Well, first off, you're going to have to realize they are prisms, and there's 3 prisms. You've got this prism, the 15 by 5 by 6. You've got this prism, the 15 by 12 by 10. And then you've got this prism with the slant that you're going to need to kind of keep in mind. I would do this, teachers, as a, oh my goodness, my brain has shut down because it's August 3rd and I'm having to remember how to do say my words. Trapezoid. Oh my goodness, this is a trapezoid prism because there's my trapezoid. So it's a 5, 12. Of course, the remainder of the 23 feet after you subtract the 6 and the 10, so 23 minus 16, and then you have to really kind of keep in mind that that's the same right here, and then possibly do the Pythagorean theorem to find that slant right there. Find the volume, find the volume, find the volume, add them all together. All right. So it looks like we're going to end up with 3,142.5. All right. Let's see. Protective liner to cover the walls, flat surface to the pool. How much liner is required? Okay, this is surface area. So, okay, we're going to have to go back and remember volume and surface area, of course, are not the same. So you'll need to go back and look at this as being surface area of these 3 different types of prisms. So find the surface area, find the surface area, find the surface area, but keep in mind the top has to come off because it does not have a liner. So please keep in mind there is no liner on the top. So once you find the surface area, subtract off this top. And that's where people are going to miss this, teachers, because they're going to forget to subtract off this top because there's no liner at the top of the pool. You're going to have a liner on the left and the right. Of course, this left back side and this front right side. And then, of course, the bottom of the pool. But that's where students are going to miss it, is they forget to subtract off the top of the pool that does not have a liner. So you're going to end up with, I believe it was, when I worked it out, 570. All right. Okay. Okay, so I'm done with that page, 111. Turn the page to 112. Okay, so example number 5 is just a bunch of words. All right. Water park. Destiny visits a water park where a new cyclone water ride has opened. On the new ride, a tunnel flows into a large funnel. And personal experience, if you've never ridden one of these, it's awesome. The slant height of the funnel is 29 meters. Remember that's your L. The surface area of the funnel is 910 square meters. Okay, they gave us the surface area, and they gave us the L. when the funnel is at its widest, what is the diameter? Okay, so you're reversing finding this. Instead of finding the surface area, you're using the surface area and the 29L to find the radius. Turn that into the diameter by multiplying by 2. All right, so that is what your task is. I'm going to let you put into your own words what I just said, because I'm not going to give you the wording for this, but I'll say it again. They gave you the surface area. The 910 goes in for the S for surface area. The 29 replaces the L for the slant height. Solve this equation for the radius, multiply times 2 to get your diameter. And don't forget, round your answer to the nearest tenth. That's one number after the decimal, everybody. All right, I am going to stop right there because I believe the practice problems are up next. And babies, that is on you. Y'all have a good one.